x to the power of 3 equals x to the power of 5. So what we're first going to do is we're going to subtract x to the power of 3 on both sides. So for this side, x to the power of 3 minus x to the power of 3, well, these two just cancel out, so we get 0 equals x to the power of 5 minus x to the power of 3. So now what we're going to do is we're actually going to factor out x to the power of 3 from this, because that is the greatest common factor of these two terms. So we have 0 equals x to the power of 3 times, well, what's x to the power of 3 x to the power of 5 divided by x to the power of 3? Well, an important property of exponents is that you have a to the power of m over a to the power of n. This is equal to a to the power of m minus n. So x to the power of 5 divided by x to the power of 3, this is equal to x to the power of 5 minus 3, and 5 minus 3 is 2, so this is equal to x squared, or x to the power of 2. So we have x to the power of 3 times x squared minus x to the power of 3 divided by x to the power of 3 is simply 1, because anything divided by itself is 1. So now we have two equations actually from this. We have x to the power of 3 equals 0 and x squared minus 1 equals 0. Well, x to the power of 3 equals 0. What to the power of 3 equals 0? The only number that fits in for x here is 0. So we have x equals 0. And this is one solution. Now we have x squared minus 1 equals 0. So if we add 1 on both sides, we get x squared equals 1. Now, if we take the square root on both sides, because we just want x, these two cancel out, so we get x equals positive or negative 1. So this would also be our answer. So now our three solutions are x equals 0, 1, and negative 1. So these three are our solutions. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 32 to the power of x equals 128, and we want to find the value of x. So our main objective for this equation is to change it into the form a to the power of x equals a to the power of y. So as you can see, the bases here are the same, and because the bases here are the same, that means that the exponents here are the same as well, because that must be true in order for the equation to be true. So what we need to do is we need to change 32 and 128, our bases, so that they're the same. Well, a common base for these two would be 2, right? Because 32 is 2 to the power of 5. And 128 is 2 to the power of 7. And 2 to the power of 5 would be to the power of x, because we're replacing 2 to the power of pi with 32. And this is equal to 2 to the power of 7. Now, when we have something like this, we want to multiply this. If we have this, we multiply the exponent, because 2 to the power of 5 to the power of x, so that's the same thing as 2 to the power of 5 times x. And 5 times x is 2 to the power of 5x, and this equals 2 to the power of 7 still. And now, as you can see, our bases are the same, so that means our exponents are the same as well. So this means that 5x equals 7. Now, if we divide by 5 on both sides, these two cancel out, and we get x equals 7/5. And this is our answer.